Hello everybody. Since many of you liked my first video, I decided to continue this topic. This is the second session of conservation of momentum I started earlier. If you're interested and did not watch the first session, please click on the link below and subscribe. In this video, I will teach some problem solving tricks and end it with some more daily life examples and activities. Let us start with a simple one-dimensional problem. A truck of mass 5,000 kilograms moving with a velocity of 10 meters per second hits a parked car of 1,000 kilograms, causing it to move at 15 meters per second. What is the velocity of the moving truck after the collision, assuming the momentum is conserved? So this is a simple one-dimensional problem, and let us consider the motion of the truck to be in the positive direction. The trick is to choose a particular direction as a coordinate system. Okay, when you start the problem, and then applying the conservation of momentum equation, that is m1 v1 plus m2 v2 is equal to m1 v1 prime plus m2 v2 prime, where the initial mass is 5,000 kilograms for the truck and its initial velocity is 10 meters per second, and the mass of the car is 1,000 kilograms, whereas its velocity is 0. Why? Because it's parked. So we need to find the final velocity of the truck, which is v1 prime, given the final velocity of the car is 15 meters per second. That's the velocity that's given in a problem. Okay, so just plug in 0 in this equation and it reduces to m1 v1 plus m1 v1 prime plus m2 v2 prime. Okay, so what we have now is the simple equation, and we just subtract m2 v2 prime from both sides, right, as shown here. So this will help us get rid of this term, right, the last term, and we are left off with just this simple expression. Now next we divide both sides by m1. Why? Because we need to find the value of v1 prime, because that's what's asked in the question. We need to seek the solution that's asked. Okay, so the expression for v1 prime finally becomes m1 v1 minus m2 v2 prime divided by m1. Plug in the values and you get v1 prime as 7 meters per second, which is the velocity of the truck after collision. Next, let us consider a two-dimensional problem. A block of mass 20 kgs initially moves at 2 meters parallel to the x-axis. After a collision with another block B at rest of mass 10 kgs, A moves at 1 meters per second in the direction that makes an angle of 30 degrees. What is the final velocity of B? So here the trick is to break it up in two components, that's the x and y component, and choose a coordinate system, right? So let's see how we work on this. Before collision, we have the mass A moving with a speed of 2 meters per second or velocity of 2 meters per second along the x-axis, and V2, that's the block B, is at rest. And after collision, like A collides with B, moves in the direction V1 prime, okay, making an angle alpha which is 30 degrees with the x-axis, and B moves making an angle of beta with the velocity of v2 prime, which we need to find. Okay, since this is a vector quantity v2, we would find its magnitude and direction by breaking up the velocities into two components, x and y, and applying the conservation of momentum for x component and y component. Let's see how we do this. The x component is m1 v1 plus 0 before collision. Okay, m1 v1 corresponding to A, and v2 is 0. And after collision, we have m1 v1 x prime, that's this direction along the x-axis, plus m2 v2 x prime. Now v1 x prime is nothing but the cosine component because it's along alpha, right? So it's given by m1 v1 prime cos alpha plus m2 v2 x prime, which we need to find. So solving this, we just get the expression for v2x prime, which is given by this equation. Similarly, the y component is given by 0 plus 0 before collision, because block B is at rest and block A does not have any velocity in the y direction. Okay, and after collision it's given by m1 v1 y prime plus m2 v2 y prime. Like this is m1 v1 y prime plus m2 v2 y prime. Okay, that's just the y components. Okay, now v1 y prime is the sign component of the velocity, because it's a component away from alpha. So this is the final expression for v2 y prime. Okay, it's m1 v1 prime sine alpha divided by m2. So what's the final velocity v given by? It's given by the quadrature of the x component of velocity and the y component of velocity. That is square root of v2x prime square plus v2 y prime square. Alright, so plugging in the values of v1 as 2 and v1 prime as 1 and alpha as 30 degrees, we get v2 prime as 2.83 meters per second. But this is not the final solution. We also need to find the direction, otherwise the vector is incomplete, right? We know the velocity, we do not know the direction, so we do not have the whole information. So how do we find the direction? We just take the value of tan beta, which is the y component divided by the x component of velocities. Okay, so that's v1 prime sine alpha divided by v1 minus v1 prime cos alpha. Okay, note that the mass terms cancel away very easily here. So plugging in these values, we get tan beta as 0.44, which is nothing but 23 degrees. Now let us consider the elastic collisions of stacked balls. A yellow ball is stacked on a heavy blue ball and both are dropped and hit the ground with the speed of v0. What is the final speed of the yellow ball? So the yellow ball has a mass of small m and the big ball is of mass capital M. Let us assume that capital M is much greater than m. Okay, and both are moving down and they strike the ground with velocities v0 as shown. So just at the time of collision, what happens is the blue ball rebounds with the velocity of v0 in the opposite direction, whereas the yellow ball is still moving in the downward direction. Let us choose our coordinate system and take the upward direction to be positive. Okay, so let's apply the conservation of momentum before these balls hit the ground. So just before collision, v0 is positive for capital M and it's negative for the small ball. Okay, so this is our equation and you understand the negative sign, right? So let's see what happens just after collision. Both the balls move upward. Okay, let's assume the mass of the yellow ball to be small v or lowercase v, which is the velocity we need to find, and the blue ball has a velocity of capital V, okay, as shown in this figure just after collision. Now both are in the upward direction, so we assign positive signs to both the velocities, and the equation of conservation of momentum gives us mv in uppercase plus mv in lowercase, right? So divide both sides by capital M and note that this term, that is small m by capital M, is negligibly small y, because it's given in the problem that capital M is much greater than the small m ball with a small ball, basically. Okay, so get rid of these two terms and we are just left off as this equation, that is capital V is equal to V0. That means the velocity of the blue ball just after collision is equal to V0. Next, what happens is, we know that this is an elastic collision, so the kinetic energy is conserved, which means that the relative velocities are conserved. So applying that, we get the relative velocity of the yellow ball with respect to the blue ball, that's V0 minus V0, okay, is equal to the one after collision, that is the yellow ball, that's lowercase v with respect to the velocity of the blue ball, right? That's uppercase V. Now what's uppercase V? It's nothing but V naught, right? From this equation we already know that. So let's plug that in here, and what we get is that the velocity of the yellow ball, that's lowercase v, is nothing but 3 times its initial velocity. So it's interesting that the yellow ball gains 3 times its velocity just after collision. This is a very interesting concept, and it is the reason of the high energy in supernova explosions, etc. Okay, there's a very nice illustration in this video if you're curious and if you want to see this. Finally, I will end this session with an illustration demonstrating implosions. Boil a little amount of water in a can till it is steaming. Next, dip the top of the can in ice water very quickly using tongs. Please remember to use tongs. So what happens is, the can implodes, right? Let's see. The moment you dip it, the can is imploding. Why does this happen? This happens because ice cools off the can and causes the steam to condense fast, and water prevents the passage of air in it. The external atmospheric pressure is of the order of 10 to the 5 newtons per square meter, and it compresses it because of the law of conservation of momentum. So this is just a simple example which you can try at home, but be very careful, okay? And if you have any further questions, please feel free to write in the comments below, and I will get back to you anyhow. Thank you so much for listening.